In this section, we'll be graphing linear functions. So let's go ahead and get started. Let's say we want to graph the linear function f of x equals 3 over 2 times x plus 1. All right, so we want to graph this thing. If this looks familiar, well, it should. We know how to graph this already. This is simply a slope-intercept equation represented by a function. Remember, the function y and f of x are not only equal, but they're interchangeable. We can see that our line has a slope of 3 halves, or 3 over 2, and our function will also cross the y-axis at 0, 1. 1 is the y value of our y-intercept, or where the line crosses the y-axis. So let's go ahead and graph this thing. So we know that the line's going to cross at 0, 1 at this point right here, and we know that we have a rise of 3 and a run of 2. So for each movement we go up 3 in the positive direction, we're going to go in the positive direction on the y-axis. We're going to go to the right 2 points. So we start here, we go 1, 2, 3, and over 1, 2. So the line's going to cross through this point and it's going to extend. Now we can also go in the negative direction. If we put a negative 3 and a negative 2, our line is going to go down 1, 2, 3, and over 1, 2. So it's going to pass through this point, and it's going to extend. All we have left to do is put arrows on the ends, just to show that the line indeed extends infinitely in both directions. And this is supposed to be straight, and I know it looks crooked. All right, so this is line A. For our notation for our axes, we still have x for our x-axis. Y, we can actually write this as f of x, and we're going to start doing that. This axis, this y-axis, is actually f of x. So for each x value we plug in for our function, we're gonna find out what the f of x value is. We used to call it y, now we're going to call it the f of x value. So this is the function of f of x. All right, let's do a few more. Let's graph the function f of x equals, let's say 4 times x minus 2 divided by 8. All right, don't get excited here. This is still a function. It's in slope-intercept form. We just need to simplify it a bit. So let's rewrite this. Let's start by distributing this 4 into the parentheses. So this becomes 4x minus 8 divided by 8. We can factor out a 4 out of all 3 terms. So we have x minus 2 divided by 2. We can actually split this into 2 fractions. So we have the fraction x over 2 and the fraction minus 2 over 2. So minus 2 over 2, or just 1. And when it comes to having our x term, I like to separate it from our fraction, so we actually have 1/2 x. Instead of writing the numerator, we just multiply it, and then we have a minus 1. So our function f of x is 1/2 x minus 1. From here, we know that our function has a slope of 1 over 2, and will cross the y-axis, or the f of x axis, at 0 minus 1, so right here. So we're going to rise 1, and we're going to go over 2. So it's going to go through this point right here. Now in the negative direction, we're going to start at the same point. We're going to go down 1 and over 2. So it's going to go through this point. And this is, forgive me again, it's not completely straight, so we're going to imagine that this is a straight line. And this is the line described by line B, described by the function f of x equals 1/2 x minus 1. So let's do a few more of these. Let's graph the function f of x equals, let's say, minus 0.75x. Okay, this is actually pretty simple. We have a slope of minus 0.75, or if you want to look at it as minus 3 over 4 in fraction form, and our line passes through the origin. Since there's no y-intercept, that means when x is 0, the function is 0. My computer's tripping out. If we plug in 0 for x, we do this over here, well, we have just 0 on the right side, so our function will pass through the origin. It'll pass through the origin, and it has a slope of minus 3 over 4. So for every 3 steps we go in the negative direction on the f of x axis, we're going to go 4 in the positive direction on the x-axis. So let's go ahead and do that. Starting at the origin, we go down 3 and over 4. So it's going to pass through this point right here, and it's going to extend. All right, and we also go in the other direction. We can go, if we put a negative on the negative 3 and a negative on the positive 4, we're going to go up 3, 1, 2, 3, and in the negative direction, 4 on the x-axis. So we go 1, 2, 3, 1, 2, 3, 4. It's going to go through this point right here, and it's going to extend. And my lines are all kind of crooked today. We're going to put arrows on the ends just to clarify that these lines indeed go infinitely. We can plug in any real number for x, and so the domain is all real numbers and the range is all real numbers. It'll actually go infinitely in both directions, so we can get any value there. All right, let's go ahead and do a couple more. Let's take a look at f of x. Let me scroll up a little bit. F of x equals minus x plus 7 over 2, 7 halves. Okay, let's be careful with our slope here. Our slope is actually a minus 1, or a minus 1 over 1, and our line crosses the y-axis at 7 over 2. So let's go ahead and graph this. So 7 over 2, we can rewrite this 7 over 2 as 3.5. So our line crosses the f of x axis at 3.5 or 3.5, which is 1, 2, 3. So right about here, and it's going to have a slope of negative 1. So we're going to drop down 1 and move in the positive direction 1. And this is going to extend. We're going to do it in the other direction. We're going to go up 1 and to the left 1. It's going to extend as such. Put our arrows on the end, and that's all there is to it. That is our line D. All right, we have time. Let's go ahead and do one more. Let's look at E. Let's say we want to graph the function f of x equals 2x minus 5. Okay, so we see our slope. Our slope is 2 over 1, and our line is going to cross the f of x axis at 0 and minus 5. 0 minus 5. All right, so let's go ahead and graph this. Minus 5. 0 minus 5 is 1, 2, 3, 4, 5. So it's going to go through this point right here, and it's going to rise 2 and run 1 in the positive direction. So we go 1, 2, and 1. So it's going to extend as like this, and it's going to go down 2 and to the left 1 in the negative direction. It's going to be just like that. And hey, we made a semi-straight looking line here. Put on our arrows. This is our function of our line E, and extends infinitely in both directions. Now, one more thing before we go. We're using x and f of x here, but we can also, we don't necessarily have to use x. We can use z and f of z, or we can use t and f of t. Functions describe various phenomena, and our variables are usually chosen correctly or accordingly. If we're talking about time, using time as our independent variable, then we would usually use the variable t instead of x. So this axis would be f of t. If we're talking about distance as our independent variable, we would generally use d for our horizontal axis, and our function would be f of d. If we're talking about cost, such as in manufacturing and whatnot, we would use the variable c. For using principal, we're not talking about your principal at school. We're talking about principal in terms of finance, our principal value. We would use the variable p instead of x, and our function will be f of p. So we'll look at some more examples in the future of using different variables for different physical phenomena in the real world. But I just want to get you a little familiar with the notation here. So I'll see you soon.